we're going to look at planar graphs and faces. So I'm going to draw a planar graph of K3 to begin with. So the planar graph of K3 is connected like this. Okay, and we don't have anything crossing, so it makes it planar. And what we actually have is representations of faces. So a face we call as an enclosed region. And sometimes you see this as R, but for this IB course, we're going to call it a face. So this is a face as it's included, it's enclosed like this. In fact, this K3 graph has two faces. The other face is here outside the region, and that might sometimes be called the infinite face. Similarly, let's do one with K4, and then we'll look at trees. So K4, but the planar representation, let's have a nice straight line. Planar representation is planar representation. It goes like this, 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 and then we loop one around here like that. And how many faces have I got? Well, I've got face 1 here, face 2 here, face 3 here, and I've got this infinite face outside the 4th face here. Now, every single time that I add a line and then I make a cycle, I make another face. So I'm going to do one more dot on here. And at the moment, this is still face 4. I haven't added an extra face because this face 4 comes around here. But now, if I add that extra line, and so I'm making one more triangle or one more cycle going around like that, I've created an extra face. And that might be quite useful for doing some proofs later. So I'm now going to look at just one extra special kind of planar graph, and that's when we have a tree. So I'm going to draw a tree. So a tree is where we are a connected graph, but with no cycles. So here's my tree. I'm going to connect this one to here, and to here, and to here. And this one's going to be up here. And let's connect this one over to here. So we've got no cycles. If I joined that up, I would have a cycle. No cycles. How many faces? It's always F1 because I haven't enclosed any region at all off. So in a tree, we only ever have one face. Now there's a really good investigation to do with the number of faces, the number of vertices, and the number of edges that leads to a very well-known formula. I'll leave you with that to do on your own.